I see that nobody has joined yet. All right, let's start the session. Hello, everyone. Welcome to the last session of this course, NPTEL course on concrete technology, NOC24-CE46, which was taken by Professor B. Bhattacharya of IIT Delhi. I am Ashirvad Satpathy. I am a PMRF Research Scholar at IIT Delhi, and I was also the officially assigned teaching assistant for this course from the side of NPTEL and PMRF. And what we did throughout this course was we arranged 2 hour sessions every week in which we discussed the assignment problems that you were given to you in the previous weeks. We also discussed some of the concepts related to concrete technology and your doubts and queries that arise regarding the lecture sessions and different concepts and information regarding concrete and its production. In this course, you were taught about cement, what is cement, how is cement produced industrially, how cement hydrates, what are the hydration products, what are the hydration reactions, how the chemistry in this, after the addition of water, how the chemistry in cement and concrete evolves through age, and how it gives us strength and durability parameters. Then we discussed different aspects of durability. We also discussed different aspects of fresh properties like fluidity and rheology. We discussed about shrinkage. We discussed about porosity, permeability, and so on. And so almost we almost touched every fundamental aspect of concrete technology. And towards the end of these lectures, we also discussed about different types of new age concrete technologies like high strength concretes, high performance concretes, lightweight concretes, or heavy concretes, as we discussed in the last lecture week as well. So, and different types of materials that are being used in order to produce more sustainable and more efficient construction, material for our infrastructure and building development. In today's lecture, this is just an extra session and is going to be the last session. So in today's lecture, we'll be discussing the week 12 assignment 12 questions. And this was the last week, 12th week of the lecture. And in this week, you were taught about um, different types of new age concretes and also regarding the rheological aspects of different types of concretes like self-compacting concrete or high strength concrete or pumpable concretes and so on. And you were at the end of this session, we will discuss some of your doubts that you might be having regarding the week 12 lectures. All right. So the first question in this assignment 12 was, which of the following is correctly matched? So they have given different types of concrete and different properties. I mean, the two major rheological parameters, plastic viscosity and yield stress, and how are these different concretes, how these in these different concretes, how the rheological parameters vary, right? So the first one is normal concrete, and it has a they have mentioned it has a high plastic viscosity and high yield stress. High strength concrete has a low plastic viscosity and low high yield stress. self-compacting concrete has a high viscosity and low yield stress. You have to pick the correctly matched option. All right. Oh, Abdul has joined, so I'll just allow your mic, Abdul. Give me a moment. It should work for you now, Abdul. I have allowed your microphone.
Sir, I am present. Just a little delayed me.
Yeah, no, no, not an issue.
Okay, sir.
Yeah, just give me a moment. Yes, Abdul, do you want to answer this question?
Question. This is self-compacting concrete, high and low. Oh, so yield stress. Yeah, it is third. Self-compact. Answer is three.
Yes, the answer is three. So you mean to say that the self-compacting concrete has a high viscosity and low yield stress, right?
Yeah, it is just like a flow because self-compacting concrete means it is just like a flow. It is coming, and the
Right.
same time yield stress also it is coming low.
Yes. Yeah, you're correct actually. So the correct answer to this question is the third option, self-compacting concrete has a high viscosity and low yield stress. And in order to explain the concepts of viscosity and how the different material parameters in the mixture design of concrete affect the rheological behavior of concrete. I have taken these two view graphs from the internet, and you can see the first one is more or less the influence of mixed design parameters. Influence of mix design parameters on rheology, and the second one is um, region of rheological behavior for different types of concrete, right? And you can see in the first case, let us say you start with a concrete which has an yield stress of some value, initial yield stress, and a plastic viscosity. So the plot is between the x-axis has a x-axis is the plastic viscosity and the y-axis is yield stress. So you start from this point and then you change the different mixed design parameters. How? Let us say you increase the water content in the mix. Then what will happen? The, the concrete rheology will move in this direction, meaning that both the yield stress will decrease and the viscosity will decrease. So this is the first case. When you increase more water, the yield stress increases, and similarly the viscosity also increases. So from a higher value of both yield stress and viscosity, it goes towards a very low value. Similarly, if you um, decrease the paste content, what is the paste content? It is the combined weight or volume content of cement and water. That is the paste content in the concrete. When you decrease the paste content, what happens is, you see, essentially the rheology of concrete is governed by the paste itself, because cement paste is the only part that is evolving its structure throughout the age, and therefore that is going to govern how the concrete is behaving at after you have added water to it. So how the concrete is behaving with time. Now, when you so as long as you keep the cement paste constant and vary the other parameters, the concrete rheology will vary, but it won't be much affected as compared to the case when you are varying the paste content too much. So when you decrease the amount of paste, what will happen? The yield stress will increase and the viscosity decreases. So the concrete moves this way, right? The yield stress increases, but the viscosity decreases. And that becomes that is the case when you can imagine, if you can imagine, when you lower the paste content, you'd see a lower slump value. So imagine a pumpable concrete, and now you have decreased the paste content, and you have made a let's say a roller compacted concrete, which has a zero slump. So even if the roller compacted concrete can still be able to be pumped to a distance, even though it'll have some, it'll require some higher energy, maybe probably, but you'll be able to pump it. But still, the yield stress is very high, and therefore you're achieving a very low slump in that case, right? So this is what happens when you lower the paste content. Similarly, if you increase the paste content, the viscosity will increase, the yield stress will so the viscosity will increase and the yield stress will decrease. So the concrete will move this way, while the viscosity increase, because now you have added more cement to it. When you increase the paste content, you're increasing the cement and the water content alike, right? And when you're increasing the cement content, the interaction between each of the cement solid particles now is the probability of the interactions will increase. When the probability of interactions will increase, the network structure that is being built between the cement solids will strengthen more quickly, will gain rigidity more quickly now. So for for the concrete to flow through a path, it will require more force, or it will flow in a at a lower velocity when you pump it through the pipe or the hose. Now when the velocity is low, it means that the viscosity is high in the concrete. So this is how the different mixed design parameters affect the rheological behavior of your concrete. Similarly, if you add some mineral additives like fly ash or blast furnace slag, this is how it affects the yield stress and viscosity and so on. In the case of cement dispersing admixtures, it could go both way. So the yield stress will anyway decrease, but it could decrease the viscosity, or it could increase the viscosity depending on the application that you want. Meaning that when you add a normal superplasticizer, it decreases your yield stress and it decreases your viscosity as well, right? So it is a water reducer, so it will work more like the increasing the water content kind of a behavior. But when you add something like a viscosity modifying agent, VMA, or something of that sort, it will essentially increase the viscosity due to its polymer structure in the chemical. So in that case, even though the initial yield stress is lowered, the viscosity is increased. So cement dispersing admixtures can have both types of effects on viscosity, and therefore you need to use the different kinds of admixtures suitable for your application and need. The second view graph shows the different regions you can categorize your various types of concrete into in the rheological plot of yield stress versus viscosity. So you see that a normal concrete lies in this region, which has a moderate yield stress and a moderate plastic viscosity. If you go towards a flowable concrete, so the yield stress decreases and the viscosity decreases a little lesser, but it remains in the somewhat in the same similar range. So in case of a flowing concrete, as I mentioned, the pumping effort that you require in the case of a roller compacted concrete or a flowable concrete, a pumpable concrete, is not much different. So the viscosity is not very different, but the yield stress has decreased so much that in the case of a roller compacted concrete, you're getting a zero slump, while in the case of a pumpable concrete, you're getting, let's say, 150 slump or so. Similarly, in the case of high strength concrete, a relatively higher viscosity in the concrete mix, but similar yield stress. The yield stress is similar, but the viscosity is increased. And this is exactly why I explained to you the more paste case. When you increase the paste content, the viscosity increases and the yield stress is more or less similar or it decreases a bit. In the case of high strength concretes, as compared to normal concretes, you are essentially increasing the cement content in the mix. When you increase the cement content, the viscosity in the mix will also increase, even though the yield stress is not affected much. And finally, in the case of self-compacting concrete, which is the question in this given assignment, the viscosity is low. Sorry, the yield stress is very low. Yield stress is low, and the viscosity lies at a very high region. So this is the case of self-compacting concrete. Viscosity is high and yield stress is very low. Again, you need to also understand that self-compacting concrete mixes also contain a lot of cement. The cement content in these mixes are very high as compared to normal mixes. Therefore, the viscosity increases ultimately. But then you want a higher some slump flow in this case. So you have to decrease the yield stress as well. In order to decrease the yield stress, they use a lot of super plasticizer as well. So this is how you can distinguish between the rheological behavior of different types of concrete cellulose. All right. Moving on to the second question, which of the following statement is true? The statement one is L-box test is a measure of viscosity. Statement two is V-funnel test is a measure of segregation. Statement three is slump flow test is a measure of fluidity. Which one of these following is true? Can you answer? Yes. Would you like to answer, Abdul? Which of the following statement is true?
Yeah, that is third, the slump flow test for measure of the fluidity.
Yeah.
That is the correct one. That elbow test is not for viscosity. It is for other test. V funnel test also not for the segregation test. That is another one. This actually the statement three is the correct one. Accepted answer.
Right,
The
right, right.
the other two are not for that exactly for those tests. That is for different elbows and V funnel. It is not for this system.
Right. You're true. So yeah, this is the correct answer. The slump flow test is a measure of fluidity. So this is the correct answer. L-box test is done in the case of self-compacting concrete mixes to test the passing ability through reinforcing bars, right? And so it doesn't test the viscosity or measure the viscosity directly. You could again arrive at the uh, viscosity equation by calculating the velocity of the movement of the concrete, but these tests are empirical tests of fluidity, right? They do not while viscosity is a rheological parameter, so these L box or V funnel or slump flow tests, they do not directly relate to the physical aspects of flow and deformation of matter. They are empirical tests developed to just give us an idea of how flowable the concrete is. So I have also probably mentioned this earlier in the lecture sessions as well. There's a distinct difference between workability, flowability, and rheology. Workability is a very crude term, meaning that a concrete is workable is could be defined as a concrete which you have yeast to work with, right? So a concrete, let's say, that is made to cast a slab or a raft foundation, that has to be that has to require a slump of 150 mm or 200 mm. It has to be a flowable concrete or a self-compacting mix. In that case, in that particular application, for that particular application, this concrete is workable. But let us say you want to cast pavement, concrete pavement, using the same concrete that you using to cast the raft foundation. Would it be possible? No, because for the case of pavement, concrete pavements, you would require a roller compacted concrete or something of that sort, has a very low slump, right? So in that case, the zero slump concrete is workable. So workability is application based. Workability is application based. Then somewhat a refined, more refined term is flowability or fluidity. So now you're distinguishing between if the concrete will flow or not. So in that case, you can directly distinguish between a roller compacted concrete and a pumpable concrete, because a pumpable concrete will have a higher fluidity as compared to that of a roller compacted concrete, right? So these tests, L box, V funnel, compacting factor, VB tests or slump flow test, all these tests of, I mean, we do call them as workability tests, but they are actually empirical tests of flowability, right? And then a rather physical definition of flow is rheology. So rheology is a the very basic definition of rheology is flow or deformation of matter, the study of flow or deformation of matter. So any material in this world is could be studied for its rheology. So we do study of ideal solids in the case of solid mechanics, but there is no such material as an ideal solid. Every material has some viscoelastic deformation undergoing throughout its age, and therefore we should be able to study the rheological behavior of it. Now, in the case of flowable materials, the rheology is very distinct. It is visible directly. The resolution of the rheological behavior is very high. But in the case of viscoelastic and concrete in its fresh state is called a viscoplastic material because it undergoes a viscous behavior and a plastic deformation as well. But in the case of viscoelastic materials like concrete in its hardened state, it also undergoes certain deformation, inelastic deformation as well, and therefore you could be able to study the rheology of it, the study of creep or shrinkage and relaxation, and those studies are related to the viscoelastic deformation in hardened concrete. Right? Let's not go over there. The second statement was V funnel test is a measure of segregation. Now, this is not a I would say this is not a right statement nor a wrong statement. In fact, because essentially in the case of V funnel test, what you're doing is you are allowing the concrete to flow I mean, under the effect of gravity, right? So if a concrete is undergoing heavy segregation in the mix, then the heavier particles, meaning the aggregates, will settle down at the bottom, and while the paste and the pore water will rise to the top. And therefore, when this segregation occurs inside the V funnel and you release the bottom opening and let the concrete flow out, it could so happen that due to segregation, the concrete takes a longer time to flow out. So V funnel test sometimes gives us an indication of segregation, but surely it is not the right test to identify segregation in concrete. There is segregation resistance tests, or in the case of bleeding, there is pressure bleeds test, and all those different tests that can be done in order to determine the stability of fresh concrete. But yes, V-funnel test can also be used to get an idea of if there is a segregation in the mix. And I know of certain European guidelines or standards on self-compacting concrete mixes where they use the V-funnel test. So initially they carry out a V-funnel test at T0, and then again they fill the V-funnel and let the concrete settle in it for 5 minutes, and then do the V-funnel test again. So if the within the 5 minutes the V-funnel times vary greatly, then you would know that this could be a sign of segregation. But this could be a sign of segregation. There is no direct relation of segregation with V-funnel test. All right. So the correct answer to this question is, in fact, slump flow test is a measure of fluidity. It shows the flowability in the concrete. Higher the slump flow, greater the fluidity. That's very direct relation. All right. The third question in this assignment was, which of the following statements is true regarding fiber reinforced concrete? Statement 1 was improves crack arresting property. Statement 2 is decreases the ductility. Statement 3 is improves the flexural strength. Which of these following statements are true regarding the fiber reinforced concrete? Yes, can you please answer?
Accepted answer 1 and 3. One improve crack arresting property, and the third one improve the flexural strength because of the fiber content. It is improve the flexural strength and the same time improve the crack arresting property also. But the other state number 2 decrease the ductility. It is not correct for this question.
Right,
That means answer is 1 and 3.
right. Thank you, Abdul. Yes, this is the correct answer. So, in the case of fiber reinforced concrete, we know that concrete is a brittle material. So, when you put concrete under tensile forces or flexural forces, which ultimately lead to tensile forces in the bottommost fibers of concrete, uh, it it appears to crack and it undergoes a brittle failure, right? Now, when you put any kind of reinforcement in the concrete, what we design the concrete to do is to allow the reinforcement present inside the concrete to take all the tensile load. And when this reinforcement fails, then only the concrete portion starts taking the tensile load. So this essentially means that we are trying to increase the ductility property of concrete, right? So any kind of reinforced concrete is ductile in nature. Now, when you add fibers to concrete, as compared to normal reinforced concrete of the same strength and same, let's just assuming the same mixture design in both the concretes, the ductility in fiber reinforced concretes could be high because of the random and continuous distribution of the fibers throughout the concrete matrix. What these fibers do is, and I've taken this picture from the internet to show you, the concrete without fibers will crack in a brittle manner with a higher crack width, right? So it is a localized failure. Localized failure. At one portion, the concrete cracks, and the crack propagates soon at that section only, and the concrete fails suddenly. But when you include fibers, which are randomly distributed throughout the concrete matrix, what they do is, once the concrete cracks, now the fiber starts to take the load, the tensile load that is coming onto the concrete, and tries to bridge that gap, right? So the crack propagation is stopped, is restricted at this point. Let's say this crack occurs, and then this fiber comes into play and bridges the gap, the crack. So the crack cannot propagate any further. Now the load is increased, and the concrete cracks at other locations. And again, the fibers present at these locations, they tend to bridge the gap, and therefore the crack width is less, is reduced in the case of concrete with fibers, and also the failure is not localized. So you'll see multiple micro cracks along the, you know, the uh, along a range of section in the concrete, not just at a particular point in the concrete. So the failure is not is not localized. So the first statement is correct. including fibers, arrests the crack propagation in concrete. And again, it increases the ductility. So the second statement is wrong. And finally, it improves the flexural strength as well, because you impart more ductility to it, and you also restrict the crack propagation in the concrete. Therefore, you allow the concrete to take a higher load in the case of flexural load application. So the flexural strength is also improved in the case of inclusion of fibers in concrete. Right. So the correct answer to this question is 1 and 3. Moving on to the fourth question, latex modified concrete is a type of polymer concrete composites, and latex behaves like rubber after coagulation. Is it a true or a false statement?
Yes, sir. It is true because latest modified concrete. Of course, it is nature of the rubber. After coagulation, it is just like a rubberized surface. It is getting.
Right.
That means it is true.
Right. Yeah. Thank you, Abdul. Yeah, that's the correct answer. So latex modified concrete is basically when you replace some part of the concrete, some part of the cementitious material in the concrete by latex emulsion. So it is basically a emulsion comes as a form of emulsion in its raw state, and when it hardens, it behaves like rubber. So after coagulation, it behaves like rubber and has elastomeric properties. So after it has hardened, it has elastomeric properties, and therefore it adds more ductility or flexibility to the concrete, and in fact more elasticity to the concrete. I would not say ductility, rather more elasticity to the concrete. Right. Moving on to the fifth question, which of the following is correctly matched? The type of concrete and their applications have been given. So the first one is latex type PCC, and the application is repair. Impregnated polymers, and the application is bridge decks. And heavy concrete, application being radiation shielding. Which of these following are correctly matched?
All are matching, sir. This latex type PCC, that is mainly using for the repair purpose, and impregnated polymer, that is bridge decking, because impregnated polymer, that means very high density and a very hard surface it is getting. That is
Right.
mostly it is using for bridge decking, and but only thing is it is very expensive. This impregnated polymer concrete
Yes.
is very expensive one. But
Right.
in the special case, especially for the bridges and all these things, it is considering this thing because
Right.
the surface it is getting very hard also. That means the wear and tear will be less in this impregnated polymer concrete for bridge decking.
Right.
That is very important for the bridges. And
Right.
heavy concrete, that is mainly radiation shielding, that is protecting, if it is X-ray room and all these things, there is some, gamma rays and all these
Right.
things forming that is protecting with the heavy concrete. That is ordinary concrete only mainly using for the this thing. That is thick. It will be more thick. I mean,
Thick.
thickness of the concrete will be more. That is mainly using heavy concrete, radiation shielding and all this for that one. That is mainly protecting the gamma rays and all these things obstructing for this concrete. That's why it is using for that one. That means all these three are correct,
Right.
except one and two and three. It is correct.
Yes. Thank you, Abdul. Excellent answer. So, yeah, all these three are correctly matched. The first one is latex type PCC, and it is used for repair. Yes. Second is impregnated polymer used for bridge decks. And when you use this polymer concretes, they essentially make the concrete impervious. So, do not allow the external sources of water, moisture, chemicals to impregnate inside the concrete or get inside the concrete. So, make concrete impervious and therefore increase the durability. Secondly, In the case of these impregnated polymer concretes, these are, as you mentioned, very costly and therefore not used for daily purposes, but they do have a higher strength, higher strength, um, and higher bonding properties as well, bond strength as well, right? And as you mentioned, due to low wear and tear related deterioration, in the case of these polymer concretes, they can be used for bridge decks, which essentially undergo impact loading from coming from the wheels of different vehicles, right? And finally, the heavy concrete is a concrete that, first of all, these sections are, as you mentioned, in the case of nuclear power plants and nuclear reactors, the concrete sections are made thick so as to restrict or shield against the radiation, the gamma ray radiation coming from within the nuclear reactor, right? And secondly, heavy concrete is a type of concrete which uses heavy aggregates such as uh, magnetite or so on, right? So the sections are also made thick, thick sections to restrict radiation. So this is heavy concrete which is used to make the nuclear reactors, the walls and sections of structural sections of nuclear reactors, right? So all these three are correctly matched, and therefore the correct answer is the fourth option, right? Moving on to the sixth question: which of the following are benefits of lightweight concrete? The options given are thermal insulation, sound insulation, both of the above, none of the above. Which of the following are the benefits of lightweight aggregate? Yes, Abdul, would you be able to answer?
Yeah, this is thermal insulation. That is the main for the benefit of the lightweight concrete. That is the main. The same time, the sound insulation also somewhere sometime it is using. That means I have doubt both of the above. That will be the correct or only thermal insulation is which one? Little confusion. But according to me, my answer will be both of the above. That means thermal insulation as well as sound insulation. Sound insulation also taken because thermal insulation mainly using for this foam material and for
Right.
what it is. That time then a sound effect also it is reducing if it is using that one. Thermal insulation definitely the temperature control and all it is coming that one.
Right.
That means,
Yes.
in my opinion, that is both of the above is correct.
Yeah, this is
Or
actually the correct answer. You're correct. Both it has benefits for thermal insulation as well as sound insulation. So in the case of lightweight concrete, we use these lightweight aggregates, and I've taken these photos from internet. So
this thermocool also sometimes using, thermocool that is granules, it is mixing with the concrete
yes,
with
to make
bonding
it
chemicals
lightweight.
also.
Yeah.
Yeah, because for my experience also, we having, lightweight concrete we use for the roof insulation and all these things,
Yeah.
waterproofing. The waterproofing, we are using the lightweight concrete for 50 or 30 18 Then after we will do the waterproofing layer over that one. That means in that case thermal as well as sound insulation also we are getting.
Yes. Yeah. So the thermal insulation comes from the uh, insulation provided by the air entrapped within the voids of these aggregates and the whole of concrete, right? And since it is not the air is entrapped within the various layers of the concrete, it insulates the temperature transfer between the inside and the outside surroundings of a given structure, and therefore it provides with a good thermal insulation. The sound insulation comes from the sound being absorbed by this hollow material, as in the case of you'd have seen it in the case of studio recording studios, or any game rooms that people have, or theater complexes wherein you'd see the wall having foam, walls made with foam insulation, so as to restrict the sound from going out of the theater room, right? So yeah, when there is a hollow material which can absorb the sound, that will give you a good sound insulation as well. So the lightweight aggregates like pumice aggregates, or even the recycled aggregates that come from recycling the construction and demolition waste of concrete, they have some previous motor attached to their boundaries, and therefore the motor is a pervious material. It's a lightweight material, and therefore it also gives you these thermal insulation and sound insulation properties. So these lightweight aggregates are used in order to make lightweight concrete, and the major benefits of these kind of concretes are thermal and sound insulation, right? This is a lightweight aggregate concrete. Moving on to the seventh question, geopolymer concrete does not use the cement in its production. Is this a true or a false statement? Does geopolymer concrete use cement in its production? Is it true or a false statement?
It is true.
Yeah.
It is geopolymer concrete does not use the cement in its production. Geopolymer itself, it is a synthetic byproduct actually, isn't it? Geopolymer.
Not exactly. So the correct answer is yes, it's true. It doesn't use cement in it. What it uses is it uses majorly hydraulic slag, and it could also use fly ash, right? And it uses activator solutions, alkali activator solutions, in order to activate the pozzolanic properties coming in this supplementary in this cementitious materials, right? And finally, it uses water to make the geopolymer concrete, water and aggregates. So these are the components of geopolymer concrete. Generally, the activator
So
solutions. Yeah, go ahead.
mostly where we are using geopolymer concrete, mostly where we are using.
It could be used anywhere actually, but the good thing about geopolymer concrete is that you need not use any cement, and the materials that you're using, the cementitious materials you're using, are industrial byproducts or waste materials, slag or fly ash, right? So essentially, you're making your concrete with a very low carbon footprint. So the major benefit of this is a very low carbon footprint if you don't consider the
That means
part of the activators, because activators
that
also
means
are chemicals which are made in industries, and therefore and they add to the carbon footprint of the whole concrete. So there is a
that,
whole debate going on between researchers if really the geopolymer concrete is a good step towards reducing the carbon footprint of concrete. That is one part of it. But the major disadvantage, and which also, in my opinion, restricts its applicability in the real world scenario, is the use of these chemicals again. So geopolymer concrete, it cannot be made in normal, Indian, I would say, a normal, very crude production of concrete conditions, like the way we make our nominal concretes using a normal construction worker who is very an unskilled construction worker who does not have the knowledge of cement and concrete and its chemistry. They just know that you add water to cement and add some sanded aggregates and it gives you a good concrete with good strength. They do not know anything about mixture design, right? So geopolymer concrete is not suitable to be dealt by unskilled workers because of the fact that it uses these chemicals which are the activator chemicals which are harmful first of all. And when you make this geopolymer concrete, the reaction is so exothermic, it releases so much amount of heat. If it is not controlled well and the mixture is not designed properly, it could release such high amounts of heat that it could affect the workers working on it, right? So I guess the major limiting factor of its applicability in real world infrastructure production is governed by the fact that it requires skilled labor and it requires a previous knowledge of working with these chemicals and the heat release and so on. I mean, cement is very easy to use. It has been being used. It is being used for almost 200 years now, right? But these are newer concrete types, and I think we need to improve our labor skills in order to reach there, in order to use these different kinds of concrete in our real world cases.
That means one side is environmentally it is friendly, geopolymer, that production and all this. But while using this one, if
There
it
is
is
a
not
problem.
properly used, if it is not used properly, then the reverse effect will affect, isn't it?
Yeah.
If it is
Yes. Yeah, it is
unskilled people.
environmentally friendly in the way that it doesn't use cement. But again, there is a carbon footprint associated with the production of the activator chemicals itself. So, uh, you know, there's a trade-off between not using cement and using these chemicals and how much you're saving on the carbon footprint itself. The how much greener are you making your concrete, and are there more easier and more sustainable ways to go about it instead of using this concrete? But yeah, anyway, it is a newer concrete, newer sustainable concrete, sustainable step towards making
This
concrete.
cost-wise, how it is affecting? If it is geopolymer concrete is costlier than ordinary concrete, or which one is costlier?
Okay. Actually, if we discuss about cost, then I would say that, of course, ordinary concrete is going to be cheaper as compared to these because cement or concrete in itself is a very cheap material. Now, since you're using these raw materials like the cementitious, the materials which are coming from industrial waste like slag or fly ash, if you have sufficient amount of slag or fly ash available around you in the locality that you're working or making your structures at, then you could probably get it at a very low cost, right? But let us say you don't have any steel plants or thermal power plants, and in the coming days, in a few years, like 20, 30 years or so in India, we might see the decline of slag and fly ash. At least that is what expected by different scientists. And then the cost of this kind of concrete should go high.
Then the main fact may be the transportation cost.
Yeah,
If it is the
because it is not
product,
locally
if
available,
it is the byproducts getting a nearby area, then it is cheaper.
then
If
it's
it
cheaper.
is very far, it is not workable. I think it is not economical.
Right, you're right. All right. Okay. Moving on to the last question of this session. Which of the following materials used for construction have highest embodied energy in the building? Concrete, steel, aluminum, plastics. Which of the following materials used for construction have the
This of
highest
course,
embodied energy?
it is of course it is concrete because the production of cement is carbon. These things environmentally it is I think about 10 to 15% it is coming from production of the cement. I think so. After the fossil I mean this
Right.
petroleum products, the The second one, it is making the environmentally harmful for because of the cement production. I think it is 10 to 15%. It is coming from the cement production. And
Right.
I think in the world, the second largest country is India is cement production after China. I think so. That means China is the first one. The second one is India.
India, yeah.
The product in that
Right.
means the environmentally it is harmful. This thing maybe 10 to 15% environmental disasters coming through this cement production. I think so.
Yeah.
That
Right.
means it is concrete is the which of the following material that is considered the highest.
Embodied energy.
That is of course it is concrete.
It is concrete, right? Yes, thank you, Abdul. So, the interesting fact about this question is that as much as it is hard to believe, concrete is not a very environmentally cruel material, if I would put it that way. It's not that harmful as compared to other products, other building materials that we use to produce our structures. But the sheer volume of concrete that we use to make our infrastructure overshadows the fact that concrete is actually a good and could be an eco-friendly material. So the huge volume of concrete in itself makes it material with very high embodied carbon energy per building. So this is a photo from I have taken from the internet, and you can see the building materials contribution to embodied energy per square meter. So you'd see that steel is has a higher contribution and ceramic products have a higher contribution as compared to cement in this case. But because per square meter or in a given building, the amount of cement that you're going to use to make your building will be so high as compared to ceramic products or steel products or aluminum or I mean I'll just consider plastics and PVCs. So the amount of concrete and cement that you're going to use to make your building as compared to these materials will be so high that it will totally overshadow the embodied energy of the other materials. So in that sense, concrete has the highest embodied energy in a building. But overall, if we talk about the embodied energy of building materials during the production process, concrete is in fact a very good material, and it does not have a very high embodied energy. Other materials like steel, aluminum, and ceramic products, or even textile and paper products, they do have very high embodied energy. But just because of the amount and the volume of concrete that we use and make every day, that is why it is contributing to almost 8% of the global carbon footprint. The construction industry is governed by the production of concrete, right? So that ends the
That
yeah, yes, Abdul,
that
go
means
ahead.
individual wise it is less, but the usage is volume wise it is very high. This
It is
concrete.
have
That's
yeah,
why it is. Yeah, that's why it is affecting much.
right.
Otherwise, steel is high and ceramic also high. But
Yeah,
the cement part is 11.7% only, but the usage is very volume wise it is very high. That's why it is reflecting very much.
see, you in the process of making concrete, the only energy intensive part is the cement, right? So once the cement is produced, and the cement contains only about one third or one fourth of the volume of your concrete,
Yeah.
right? So and all other parts, all other components in your concrete, be it aggregates or water, those are all natural products, naturally available materials, and their beneficiation also doesn't contribute much to the carbon footprint. So concrete will be a eco-efficient material as compared to steel. Let's say we have to extract the minerals and the metals from the ores, and we have to make this high temperature transformations into molten material and mold them into shapes and use some quenching methods to cool them down and so on. So they require a lot of energy in their production process. So these other materials would have a higher embodied energy. But as you mentioned, just because of the volume of concrete that we make and use every day, that totally overshadows every other material, right?
Oh, okay, sir.
Yeah. So that ends the session for today. And in fact, that ends the session for this course. All the sessions for this course are over. And I guess you have your certification exam on the 29th of this month. I'm not sure exactly.
Uh, that is in 27. I already got
27.
the timetable. I already received. That is 27th. Is the
27.
project examinations. I am attending for that one. I am already
Oh,
registered.
okay.
I applied all, I done more than 7 courses. I done NPTEL. All I applied for the examination, and all of them I got the certification also. Some courses I got the LH certification also. That means 70% and
Elite.
above I scored.
Right, right. You,
LH.
you had told me that in the last week. Yeah, yeah. This is
Actually, what I
interesting,
am
actually.
doing, I'm just updating and even my knowledge also, because now I am not making any service or retirement or all these things. But
Right.
my experience I can contribute to some others also, for
Yeah,
younger
this is
generation.
actually
That's
interesting
the
for
main thing.
us, in fact. Yeah.
Yeah, yeah. And I am very much appreciating for this NPTEL courses and all this. Still, I am suggesting so some of the younger generation people, you just go for this one, this one, this one. Always I am suggesting people,
Right.
for this because the Ministry of Education they are doing a very huge amount spending for this one, and they are not charging anything a single rupees for fees and all
Right.
these things. Then these facilities they have to utilize maximum. Not only that, this platform is very high. All IIT professors and all these things dealing and those things. I am very much happy for this, their classes and all these things.
Right.
Mostly I am, sometimes if there is time, definitely I go for, their classes and, that is a very good thing.
Yeah, yeah.
Anyhow, for the younger generation, they have to utilize. And one more thing, sir, this research for Prime Minister, what it is called, a PMR, that is elaborate from that one, PMR.
PMRF. It is Prime
That
Minister's
is,
Research Fellowship.
this is how many years you have to do this one?
This is
3 year
for
or
four
5 years?
years to earn your PhD.
Yeah, yeah, yeah. What is your core subject for this one? MTech, which was your core subject?
So I did my master's in structural engineering, and
Engineering. Okay.
yeah, and
Yeah. Then
then
now
my PhD is on cement chemistry.
cement chemistry. That is chemical, chemical part. It is coming.
Yeah,
Yeah.
right.
Mm.
Yes, majorly on the fresh properties of cement and concrete.
Sir, you are from which part of India?
I'm from Odisha.
Orissa. Yeah.
Yeah.
I am from Kerala. This near Kochi.
Oh, okay.
I
All
don't know.
right.
Already I used to visit in Odisha and Bihar and all these things. During actually I was running some business in Oman as a construction company.
Right, right, right. You
Uh,
had mentioned it.
That time I used to come there for recruiting some peoples and even for engineers and laborers and all these things I recruited from there. So many time I used to visit there,
Oh, okay,
most of
nice.
the countries. Now little, I am little relaxed mood. Then I am
Yeah,
utilizing this type of activities.
yeah.
Okay. Anyhow, thank you
Yeah,
very much,
this
sir,
is
for
this was in
your
fact a very good learning experience for me also. Like the way I
yeah,
come and
practical.
discuss with you different concepts of concepts related to civil engineering, and the way I get your inputs and insights,
Yeah,
majorly
yeah,
on the construction side of it. I mean the applications and
yeah,
real construction site experiences that you share, and
yeah.
yeah.
Actually, I got more than 30, 35, 40 years experience I have in the
Oh,
construction
nice.
field.
Yeah, yeah.
Mainly
Yeah,
it
it's
is
good
done
to
in the
see
material.
people like you with so much experience and even at this age where you should be enjoying all your leisure time, you're in fact interested in gaining knowledge about newer
Yeah, yeah,
concepts
because
and yeah,
because nothing is finishing up to
yeah, exactly.
till our yeah, it is updation always. It is going on. There is no end for the education. That is my thinking is in that way. Not only
Yeah.
that, I actually in my experience, I done different field also. Not only in my total this Gulf experience, even I work for consultant engineer as a consultant engineer. Also, I worked marine work. Also, I done
Okay.
hydrographic survey. Also, I done. That is all done
Oh,
in the Gulf
nice.
countries Yeah, hydrographic survey also, I know very much aware of the hydrographic survey and
Okay.
the GPS survey. All these things I done because all updates and normally for the equipment and everything we used to get it in Middle East only
Right,
before
right.
20 years back we used to get it in Gulf countries. That is all the
Oh,
updates
nice.
and equipment everything is used to come there. But India now it is okay. Now we are very much advanced in India also. All the
Right.
equipment everything really because most of the out of my 40 years service, around 35 years I was outside.
Oh,
Still I
okay.
having company and most of the work was construction.
Okay.
Marine work also
So
done for
now you're not running your company, like is it being run by
company
somebody
is
else or?
there. Company is still there. My elder son is running that company.
Oh,
He's still
okay.
there in and
Okay.
company because we were in investor there in Oman.
Oh, all
Yeah,
right.
that
Okay.
means investor company. But during that COVID time, it is very badly affected. We
Yes,
used
I
to
know.
because we used to make the college building, Ministry of Education college building, Ministry of Sports, this stadium. I having good
Okay.
experience the stadium, gallery, and all this thing I done.
Oh, nice.
Uh,
Lovely.
and buildings too much I done. Building and computer, structural cabling, electrical, everything I used to used to do.
Okay.
Yeah, and sometimes I used to work in as a material engineer. For the mixed design, everything I having very good experience for mixed design, concrete mixed
Okay.
design, and for road mixed design, all the and field densities test and all test I used to, especially for the mixed design, I used to make the cube test and all these things. Very commonly I used there.
Right.
Very because that time we used ASTM method, American Standard of
Yeah,
Material
yeah, yeah.
Testing, all that.
Majority of the and
Yeah,
the Middle East countries, they do use
country-
the
yeah.
ASTM standards.
When I used to work in Saudi Arabia, I
The
was working as
concrete
a
design
geotech.
should will also be. I mean, you'd be using the ACI codes, right? AC and
Yeah,
ACI
yeah, yeah.
codes. Yeah.
ACI code. And the method absolutely, because the ASTM is a very, very large,
Right.
very expanded. And all method, it is very specifically mentioned how to take the sample, how to make how to maintain, how to, all these
Yeah,
things, it
yeah,
is
everything
mentioned.
is very specific in those codes. I know.
Somebody, little knowledge in the technical and knows how to read and all these things, then it's very easy to catch all these things. Only a little guidance they can use to make all the testing facilities there.
Right.
I used a lot of all concrete was ready mix concrete before suggesting some concrete for some project. We personally go and take the sample from different sources and grading everything. We calculating and in lab we having a lab also. We do all the lab test everything and we proposing what is to do and we suggesting this thing to the consultant, then consultant making the specification everything accordingly. Then after it final it is going to the tender stage and specification everything consultants doing. Then after it is coming to the tender, then it is goes to the contractor. That time the contractor has to, contractors all the dealing controlled by the consultant. There is RE will be there in the site,
Right,
resident
right.
engineer.
Mhm.
All these things we are very, very systematically we done there. It is very, very systematic. And even for the concrete pouring day, every 40 cubic meter, we are used to take at least one sample. That means for STM, this four sample we will take.
Oh,
Then
okay.
one sample take 3 day. After 3 day, then another sample we'll take for 7 day. Then after 14, then two sample we'll take it 28. Because you know why? The stipulation of form work we have to do little early for getting the idea about the strength of the concrete. We are taking one sample before 28 days. That means three
Right.
day or 7 days or 4 days. Then we know that is 60% it is attained. Definitely it will cross the 28 days strength. It will cross the
The
specified
target.
strength. That
Yeah.
means yeah, target strength it will get according to our experience and all this thing. We knows it.
Right.
Then we will give the sanction to the contractor to proceed for the further. I mean for the further casting and all this thing. Otherwise,
Mhm.
because we having very stipulated time for the project completion. Then
Okay.
if we go for all waiting for the 28 days, next stage 28 days, then it will
It'll take a long
all
time. Yeah.
it won't affect there. That means we having some other measures to control all these things.
Right, right, right. You
And
use these
and
accelerated tests to do those.
yeah. That is, I used to make all the tests and all this. That's why I am very much interested for this. Only problem, nowadays there is some, for the proctor examination, there is a little I am hesitating because of the these empirical formulas and all this
Yeah,
I
right,
have to remember.
right,
Still,
right.
I am remembering. That's
Okay.
not very bad for me, but still, it is good for me. Okay, that is good in that way.
It's good to see
Okay.
people like you with so much enthusiasm at this stage and
Yeah,
with so much experience. You serve as an
yeah, yeah.
inspiration to the youngsters.
Sir, if you don't mind, you please give me your details, email address, and sometime if I having some doubt or anything, I can contact you
Yeah,
in
you
future
can,
also.
if you want, you can find me on LinkedIn. I'm very pretty much active over there, and we can
Okay,
connect.
okay. Because for the design wise, or if I having some doubt or something, then I
Yeah,
can
no
ask you.
issues. Yeah.
And now here you are using this MTech. You have done the structural design. It is start which
Pardon?
manual or method or software method you are using for structural design.
So generally, I mean, during the courses in our masters, we used to do it manually. So in order to capture all the nuances of the design procedures. But after my masters, I used to work for a construction, I mean, for a design and construction firm for 1 year
That is
almost. And
pro.
there I used to work on AC and ACI standards. The construction company worked on designing the wastewater and water treatment plants across the United States. And
Mm.
there I used to work on these ACI and AC codes for
No,
designing
no.
water
So,
tanks and so on. So there I
yeah,
use the different softwares for structural design. Yeah.
Start Pro maybe. Start Pro
Yeah,
is a
sometimes
structural.
Stat
It
Pro,
is,
majorly sometimes Stat Pro, they do have, majorly they do have some Excel sheets already prepared in-house, and you can use those templates. And then for load calculations, they had this energy calc or something like that. I don't remember exactly the softwares. They had all the licenses that was used, and for I mean steel design, bolt design and on, they had this Hilti software. So yeah, different
uh,
softwares for
what,
different purposes.
what I experienced for the design by using the Start Pro, the steel actually normal steel is higher than if it is exactly if you go for the manual method. Then steel requirement will be less compared to Start Pro. Start Pro because we are the maximum some
Yeah,
say the same thing is a ditto we are applying. That means normally
right.
the steel
And
part will be high.
that is probably why people. I mean, I have not worked on ETABS much, but people do prefer to use ETABS for reinforced concrete rather than Stat Pro, because Stat Pro doesn't give you these very economical designs in the case of
Yeah, it is not.
concrete.
But for a big project,
For
actually, the
yeah,
advantages time wise and all this, it is required because
and it allows you to use this finite element analysis for your shells and plates and structures look like those shells and domes and all that.
and it is very good for the steel structures also.
Right,
Steel
it is
structures,
good for steel structures. Yes.
steel structures, and all the nodes and all these things very precisely it will calculate. That
Yeah,
is very
so
very.
for the industrial sheds and all with
Yeah,
containing the steel structures, we used to do it on Strat Pro majorly.
it,
But
it is.
majorly, most of the normal. I mean, I worked for only 1 year there, so I was pretty I mean junior among all the other engineers. So I used to get only very basic designs of water tanks or so on. So those were just in-house Excel sheets, templates that they had already developed, and we used to work on them.
Yeah. Excel sheet. If you having more aware of all Excel sheet, then we can make too much formula in that
Yeah,
one. We can do
exactly.
it
Yeah, and you
easier.
have a very good control over how you want to
Yeah.
manipulate the input parameters and so on.
Yeah. Anyhow, thank you very much for your
Yeah,
interaction and
thank you. Yeah, thank
yeah,
you, Abdul.
and we can touch it in future also because I'm very
Yeah,
much happy.
yeah, sure, sure. You will get in touch. So yeah,
Oh,
this was also a very nice journey, learning experience for me. And all thanks to lastly to Professor Bhattacharya for designing this wonderful course. And hope
Yeah. So
you all we all learned a great deal from this course. And all the best to you for your certification and for all your future endeavors. Yeah, you're
okay.
saying something,
No, no, no. Okay, okay. Thank you, sir. I am very, very happy with Professor Bhattacharya. His class was very, 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 very nice because I
right?
experienced so many professors. Out of you, one was he, and one more one. I done one geotechnical engineering course IIT Bombay.
Right.
It is done by Doctor Singh, or what it is called, what it is, D Singh or something,
Okay.
something like that. His class was very fantastic because out of all his class was very fantastic.
Okay.
Uh, he is from IIT Bombay.
Okay.
About 1 year back, I done this geotechnical engineering. Why
Hmm.
I took the geotechnical engineering? I had some experience in Saudi Arabia. I was geotechnical engineer there. That means so geotechnical soil investigation and material testing I done there.
Okay.
That's why I interested. Then I done this one. Without less effort, I could finish that course very easily.
Okay.
My practical experience was there, and the soil investigation, drilling, bore
Oh,
drilling, and all,
yeah, yeah.
and SPT standard penetration test, and sieve analysis, and all this thing I done in connected with the soil investigation test. That's why I did that course.
All
I
right.
I finished 1 year back then. I think his class was very very nice. I am very very much appreciating him. It's
Okay.
D Singer or something. I forget his name.
Okay.
It is from IIT Bombay. IIT Bombay. I actually that course done two process done. One it is this one geotechnical course number two and course number one.
Hmm.
One was another professor, and the second one was another
Okay.
professor.
Yeah, yeah. Got it.
That's why, my opinion, this Ministry of Education done very good thing for, this
Yeah.
enhancement for course, and we have to utilize all these things, all Indians, not only here, outside India also they can use because we are getting very good platform, especially for IIT. All the people cannot go for directly, cannot go for the IIT, but
Right.
at least we can utilize this platform like this. IIT we can utilize. That is, yeah.
Yeah, I mean
Uh,
that's true.
not only that, this is free of cost.
Yeah.
If you go for some other course, how much money we have to spend for this one?
Yeah.
Such a fantastic course.
Yeah, the quality of I mean
Yeah,
information
you
that you
know,
get from here, and
uh, uh,
without having to pay anything,
yeah,
it's just
yeah,
incredible.
and their audio and video very fantastic, very,
Yeah, yeah.
very, very clarity and very good things. It
Yeah.
is better than in the presence. Better is to go for the video.
Right.
Yeah, that much quality is there, and only thing is interaction may be little less. That
Yeah.
is the only. At least you people get giving the interaction. That are so good.
All right. We are also trying our best. Let's see.
Oh, okay, okay, sir. Thank you.
Okay.
I'll
Okay.
touch.
Bye bye. Let's close
Thank
the
you.
session for today. Yeah. Bye bye. Thank you.
Okay, thank you very much. Have a nice day and good night.
Yeah. You have a good night too.